Suppose you did a Lagrange multipliers problem, and you wanted to check. Well, if it's an odd, you can check the answer in the back, but you want to be able to check yourself. So here's the idea. We're going to do the Lagrange multipliers problem that we did on Friday at the end of class. And we're going to see how we can check it, as if we don't have any other tools other than our own brains. This is some paper. So here's what we got. Oh, you're going to want a calculator. So here's the idea. We did this problem. We did this paraboloid, and we had a plane. And you can actually see what's going on. This plane goes through 1, 0, 0, 0, 1, 0, and 0, 0, 1. So that little triangle there represents a plane that's tilted into a corner. It's going up like that. And then this paraboloid has its lowest point at the origin. It's this cup facing upwards. So this plane is cutting through this cup. You can see where it's going to be the highest. It's going to be the highest when x and y are both negative. And you can see why right there. When x and y are both negative, that z has to make up for it. So you get a big beefy z. But I'm constrained where this plane hits this surface. So I can't just get z infinitely big, x and y infinitely negative. I'm limited. So where is the place where this happens? We did this on Friday, and it led to y equals x, which makes perfect sense with this picture. Because look where that plane goes. And the highest place is going to be where x and y are both negative and probably equal to each other. That makes sense. So having this led to put x in there, put x in there. You get a quadratic in x. Solving with quadratic formula. We did this yesterday, but didn't do it in detail. Here's that x value with lots of decimal places. And here's the max z with lots of decimal places. We did that stuff. Now here's how you check. So the check starts here. Pick an x out of thin air that's close to the x you got. And think about it. You've got this plane cutting through a paraboloid. We think we got the max z. But if we take an x value that's close by, we got to get a corresponding y value and then see what z value we get. That new z value should be lower than the original z value if that original z value was a max. So let's check it out. I picked negative 1.4 out of thin air. It's close to negative 1.366. Now here's the key idea. You have to get a y that doesn't use the Lagrange stuff. Because if you use the Lagrange stuff, you're going to be forced to find the x and y we already found. So don't use the Lagrange stuff. Just use these guys. You want to find an x and a y that satisfy both of these. So when x is negative 1.4, you get to put that right there. That's 1.96. And here's a negative 1.4. I shoved it off to the other side so I get z equals on both. Now I got z equals on both. Set them equal to each other and look what you get. A quadratic in terms of y. You can solve that. So you solve for y, and one of the two numbers that it gives you is negative 1.33066. That's the one we want. That will go with this x, the negative 1.4. It'll satisfy both of these equations with the same z. Now you just find that z and see what it is. So I found that z. I used the x squared plus y squared on my calculator. And I got this z, and as soon as I wrote 3.730, I knew I had won the game because I had 3.732 before. Aha! I got a slightly smaller z. That's good evidence that z equals 3.7320588. That's good evidence that that's a max. So that's how you check your own. You got to pick a value that's close to what you got from Lagrange. Don't use the Lagrange stuff. Just find what kind of point you can get out of this. As soon as you have a picked x, it should be enough to force you to get all the other numbers. And then you find the z that goes with it and see if you got a maximum. Or sorry, see if you got smaller than the maximum, because then you win. So good luck with that. Do some Lagrange multipliers and try checking them yourself. It's good practice. It makes you think about the problem. It makes you think about that structure because you got that paraboloid and a plane cutting through it. And all Lagranges are like that. You've got some kind of surface or hypersurface and some lower dimensional object cutting through. And you got to find the place where whatever you've got this variable by itself, the thing you're supposed to maximize, find out where that is. All right, talk to you later.